Hey guys, welcome back to my channel. Happy Sunday, everyone. So, in this video, I'm going to talk about TCP three-way handshake, which holds paramount significance in reliable network communication between a client and a server. And I'm going to show you how to check that in real time using a Wireshark packet capture application. Okay, so I'm going to use a open source tool, okay, open source intelligence tool called Test PHP web page. Okay, and it is provided by Accuratics. I will use that to show you how to quickly read a three-way handshake communication between my PC and the web server, as in the test PHP web page. Okay, and let's get started, guys, on the practical demonstration part using Wireshark application. I've already made several videos on Wireshark earlier on how important the tool plays in networking basically. Okay, and I'm just going to give you a small information with regards to three-way handshake. Basically, it has three parts: SYN, SYNAC, and ACK. Basically, the client first sends a SYN request to the server, and server responds back with a SYN acknowledgement message, and then finally the client acknowledges back using an acknowledgement request. Okay, and this is called three-way handshake, guys. First goes the SYN request from the client, and then server responds back with a SYNAC, and then finally the client responds back with an acknowledgement message or request. Okay, and this particular three-way handshake plays an important role in identifying a lot of network related issues, like there could be congestion, network congestion, packet loss, etc. And even sometimes there could be client side issues as well as destination, as in the server side issues, which helps us in troubleshooting a lot of these issues. Okay, let's quickly get started, guys. I will start Wireshark now. I'll run as administrator. So I'm facing some issue here, not able to open it. Let me see the issue. Some issue here, not able to move the cursor. So basically, there are sort of failure scenarios where the handshake, if it fails, that will be due to, let's say, if the server does not respond with a SYNAC request after receiving the client message or the client's initial SYN request, the connection cannot proceed. As a result, it will indicate a server side issue. Okay, in case if there is a lost in SYN packet, okay, if the client SYN packet never reaches the server, the handshake as a result fails, and it means that there is a client side problem, as in there may be issue with my PC here. Okay, if my SYN request is not reaching the web server side. Okay, so this is how we normally use this three-way handshake to determine whether it's a client side issue or a server side issue, or whether there is a wider network related issue. Okay, so sometimes network congestion, hardware failures, software bugs can also disrupt the handshake between the client and the server, as well as some firewall rules within infrastructure. Within the organization's infrastructure, firewalls may block the traffic, preventing successful handshakes. As a result, handshake can fail as well. So all these factors needs to be determined by the network security engineer or network engineer, or whosoever the professional is handling the network part. Okay. And remember, successful handshake is crucial for reliable communication. So if it fails, hosts can won't be able to exchange data, as in the client and server cannot exchange the data. Okay, so hence why I previously mentioned that three-way handshake is a very important component within your network IP TCP model. My PC needs a servicing, I guess. I'm still not able to move the mouse cursor. However, I see the recorder running in the background. Let me see. Okay, finally, there you go, guys. I was able to. Something has happened. So, so what I will do is I will first try to pull it the IP information, okay, of my PC and the web destination. So this is the destination, guys, which I'm going to use. Apologies. So guys, I'm looking for my IP address here. This is the IP address of my local PC, as in my wireless adapter, as well as this is the IP address which the test PHP web page resolves to. So this is the web page, guys. I'm going to use to help you show how the handshake happens in the backend using the Wireshark application. So I'm quickly going to run the Wireshark as administrator. So basically we're going to use a filter, guys, a Wireshark filter. So I'm going to quickly refresh the web page here so that Wireshark captures the traffic here, the backend. So guys, I'm going to type tcp.flags.syn. Alright, is equal to 1, and then I'm just going to give 2 pipes, and then just type again tcp dot flags dot. So I have to use brackets here, open close brackets. So the first portion of the filter is over, and we will be doing the second portion, which is tcp.flags.syn, and then I will add another portion to it, just tcp.flags.syn, tcp.flags.ack, okay, which is the server response, which responds to the SYN-ACK request or SYN-ACK message, okay, and then one denotes that kindly go ahead and check only the packets that has been captured. So basically the one denotes to capture the packets, okay, capture the visible packets. If you put in a reverse condition 0, it will ignore the capture. I mean, it will ignore the capture. Basically it will not show you the communication, okay. One is to show you the communication, okay, and the final portion is the tcp.flags.syn, the tcp.flags.ack, which is the client responding with the final message in the form of an acknowledgement, okay. And I will define source and the destination at the end of this filter. So I've defined the final portion, guys, which is the last one, tcp.flags.ack is equal to 1, which means it will show the communication from the client as well as part of the final message, the last step which the client does to the server by responding via an acknowledgement message that I have received your message, hence the connection between us is successful, and then both the client and server go to an established connection state, okay. And here now I'm going to define the source and destination here, which is ip.source is equal to my IP address, my wireless IP address, okay, and then I will define the destination IP address of the test PHP web page. So I will hit enter, guys, okay. So let's see if the query returned us with the desired outcome, but unfortunately it has not. It has not returned us the desired outcome. So I'm going to close the Wireshark and do it from the scratch. Maybe some issue with my filter or query. Okay, I will rerun it for you again. Apologies. Let me see if I have copied the query somewhere. Notepad. No, I have not done it. Hence, we have to retype the query again. Yeah, let's do it again, guys. If you don't mind, I'll speed up this video, guys, for you. If the video is becoming lengthy for you, so I will recite the query once again so that everyone is aware. So the first portion reads, guys, tcp.flags.syn is equal to 1 with open close brackets, and then couple of pipes followed with the first portion. The second portion is again, you've already seen the previously. It's again tcp.flags.syn first, and then and tcp.flags.ack, which is the server's response. Okay, we're looking for the server's response. So the second portion is over, and the last portion is again tcp.flags.ack is equal to 1, which is again the last confirmation from the client, which is my PC here. Okay, and everything must have a open and close brackets, guys. Okay, and the value defined as 1, and then finally and I'm going to define my source and destination here. Source is my PC, and destination is the web page IP address to which it resolves. And then finally I'm going to hit enter. Okay, after fire completion of this query, and now I have got the desired outcome, guys. So basically I've got the desired outcome. As you can see, the very first packet which my PC sent, that has a SYN request. Let me show you. All these are TCP streams, guys. All these are coming in the form of TCP communications. As you can see, it is quick to highlight us all the communications that is happening between source and the destination which we have defined, and it's particularly targeting the three-way handshake here. If you see that line mark, you see this marking over here in a bracket on the left corner. Okay, and you can see the source IP, which is clearly my PC's address, and the destination which I have already defined. And you can see the first request. You can clearly see the client PC sending SYN request first, and followed with a get request, which you can ignore. Okay, and the next request, you can see clearly the server responding to my PC with a SYN ACK request, and the final one is the acknowledgement. I can go to TCP stream. I can follow the TCP stream to remove that get request here. So this will purely focus on just the three-way handshake communication, SYN, SYNAC, and then ACK. You can clearly see these are communication happening between source and destination, as in my PC, and the web page as in the destination. And you can clearly see the three-way handshake has happened successfully without any issues. And that is obvious because we have not encountered any issues here. We were able to successfully access the web page, and that is the result which has proven that the handshake is happening successfully between my PC and the destination web server. So this is how, guys, use Wireshark to determine whether there is a successful handshake between client and destination. Okay, this is a powerful tool, guys, which is your Wireshark used to packet capture within a particular networking device, or within a client. You can run it anywhere here, client PC or destination PC, or on all the network interfaces that you have. If you want to capture, basically this will capture all the network interfaces, okay, along with your local PC. Okay, something you call as promiscuous mode, which is enabled by default. So basically I wanted to rerun the query or filter again for better visibility of the audience. I'm typing the query again so that you make a note of it somewhere, because it's a custom query that I have built. You may or may not found it online. It's purely based on the logic that I have built this filter, this custom filter. Maybe you can find it in online articles as well, but I did not find it online. So it has this query has basically three filters, guys, three portions. First portion defines the SYN request, to log the communication or show the communication for the SYN request. The second one is SYNAC request from the server, and the final portion, the third portion, is the acknowledgement request going from the client PC. So the value you should always define as 1 if you want to see the request, and if you want to ignore that request or that communication, you just specify. You have to just specify inversely as 0. But I want to basically view the communication, hence why I am defining the value as 1, the flag value as 1, okay, which is I want to view the communication. Finally, I am defining the source and destination. Because I want to be specific, I don't want to list all the communications in the form of a handshake from all the other interfaces within my network. So I want to be specific, just restricting to my PC alone. Because promiscuous mode is on, Wireshark may capture everything, traffic coming from all the devices from my network. And so that's how I landed to this page, guys. After entering that filter, I was able to successfully view the three-way handshake communication, and then I followed the TCP stream to negate that get request which was popping up. I don't want to see the get request and just see the TCP streams, TCP communication, by following it explicitly. So hope this video was informative, guys, and if you found this video helpful, I would request you to put a like to this video, as well as subscribe my channel for more useful videos like this. Until then, stay safe, eat healthy. Cheers, tada, bye bye, guys. Have a nice day.